How to classify materials in either conductors or semiconductors or insulators. To overcome this, EBT comes into picture. What is EBT? EBT means energy band theory. In this theory, I have mainly three bands: valency band, conduction band, and forbidden band. Everybody know in an atom. Let us consider this is an for this atom, it contains nucleus at the center. That is, both proton and neutron are combined together to form this nucleus, and it also contains the shells or orbits. Each and every orbit has its own energy level, and each and every orbit contains 2n square electrons based on the shell number n. The outermost orbit is called valency band, and the electrons in it are valency electrons. Generally, these electrons do not provide conductivity, but due to the electrons' force of attraction from nucleus is very low, the electrons which are present in the valency band are valency electrons which are require very less energy. That energy is called energy gap. This energy gap is required to electron which is present in the valency band to get excited into the conduction band. Basically, this valency band is formed by the valency electrons which are present in the outermost shell. These valency electrons are having high charge, that is, they are having high energy, so they form a covalent bond in between them. So valency band is formed by valency electrons. Comes to conduction band. In semiconductors or insulators or conductors, what happens is, in conduction band, the free electrons are present. This conduction band is formed by free electrons. Free electrons is nothing but valency electrons plus energy gap, which is required to excite from valency band to conduction band to cross over the forbidden band gap. This forbidden band gap is some energy gap between higher excited electrons, that is free electrons, and the covalent bonded valency electrons. If we consider about insulators can have this forbidden band gap is very high, that is up to 7 electron volts. EG means electron energy gap. FB means forbidden band or forbidden band gap. Comes to, for these insulators, the resistivity will be highly positive, that is 10 power 7. If you take an example of diamond, the energy gap is 6 electron volts. So it is heavy charge which is required to an electron in an atom, so that the electron in the valency band get excited to the conduction band. So in insulators, mostly the conduction is not possible. If you come to conductors are, we know, highly conductive. For these conductors, valency band and conduction band are overlapped with each other. That is, this conduction band as well as this valency band are overlapped. That means there is no energy gap or forbidden gap are present. No forbidden gap is present. That is, resistivity is highly negative. Resistivity is negative means conductivity is high. In the same way, the most interesting material, that is semiconductors. If you consider these, it contains the three bands, whereas energy gap is 1 electron volt approximately. Resistivity is negative, so these semiconductors also conduct. At 0 degree temperature, the valency band is full of valency electrons, whereas conduction band is empty because no free electrons are present. At room temperature, what happens is the room temperature that is thermal energy gets absorbed by the valence electrons which are present in the valency band, and these valence electrons cross the forbidden band gap whenever they acquire an energy which is greater than energy gap. Then valence electron plus that energy gap energy taken electron will get excited to conduction band, and they become free electron which are responsible for conductivity. If you see this, the valency band is not full. That is, some of the electrons get excited and jumps into the conduction band. That's why conduction band is also not empty. So from the above observations, we can conclude increase in temperature in semiconductors will increase the conductivity in semiconductors. At 0 degrees, if we consider the mostly used semiconductors, the energy band gap of germanium is 0.7 and silicon is 1.21 electron volts. At room temperature, the energy gap of germanium is 0.7 electron volts. For silicon, it will be 1.1 electron volt. In most of the semiconductor industry, we are using silicon for manufacturing materials, semiconductors like BJTs, FETs to form microprocessors for our day-to-day life usage for computers, PCs.